Ever wondered how TensorFlow works in neural networks? Today, we are going to unravel the mystery. Welcome to the fascinating world of TensorFlow, a powerful open-source software library developed by the Google Brain team. It's specifically designed to create and run complex mathematical computations, making it a game-changer in the field of machine learning and neural networks. Imagine TensorFlow as the brain behind the operations of many Google services. Yes, the search algorithm that gives you accurate results in a split second, that's TensorFlow working its magic. It's not just Google. TensorFlow is the driving force behind numerous popular applications, making our lives smarter and easier. Its ability to handle large-scale neural networks and its flexibility to work on different platforms are just a few reasons why it's hailed as a significant breakthrough in the tech world. Having understood what TensorFlow is, it's time we delve deeper into its functionality in neural networks. TensorFlow and neural networks, a match made in computational heaven. But how do they work together? TensorFlow, a brainchild of the Google Brain team, is an open-source software library for high-performance numerical computation. It's designed to be flexible and efficient, capable of running on a wide range of platforms from laptops to large-scale cloud systems, and even on mobile devices. Now let's delve into how this powerful tool plays its part in the realm of neural networks. Neural networks, or more specifically, artificial neural networks, are computing systems inspired by the human brain. They're composed of interconnected nodes or neurons that process information. When TensorFlow comes into play, it's used to train these neural networks to learn from data and make predictions or decisions without being explicitly programmed to do so. In TensorFlow, the computations are represented as data flow graphs. Each node in the graph represents a mathematical operation, while each edge or tensor, which is where TensorFlow gets its name, represents multi-dimensional data arrays that flow between the nodes. The process begins with data feeding. The data is fed into the input layer of the neural network. It then flows through the network, undergoing various computations at each node. This is where TensorFlow's strength really shines. It can handle these complex computations swiftly and efficiently. But the magic doesn't stop there. Once the computations are done, the results, or output, are compared with the desired output. The difference between the actual and desired output, known as the error, is then fed back into the network. This is a process known as backpropagation. The network adjusts its internal parameters, or weights, in order to minimize this error. This iterative process of feeding data, computing, backpropagating, and adjusting continues until the network is adequately trained. In a nutshell, TensorFlow provides the framework for all these operations: the creation of the data flow graphs, the computations, and the backpropagation. It's like the backstage crew in a theater production, silently ensuring that everything runs smoothly. TensorFlow's ability to execute complex computations is what makes it an invaluable tool in running neural networks. TensorFlow isn't just popular without reason. It has several benefits that make it a go-to tool for neural network implementation. One of its significant advantages is its ability to perform efficient computations. TensorFlow achieves this by using data flow graphs for numerical computations, which enables it to execute complex operations swiftly and effectively. Notably, TensorFlow is highly scalable. This means that it can support large-scale, complex neural networks, making it a suitable choice for both small projects and large-scale machine learning tasks. In addition, TensorFlow offers unparalleled flexibility. It allows users to write their code in several programming languages, including Python and C++, and it supports various kinds of neural network architectures. Lastly, TensorFlow has a large community support. This vast network of users and developers means that help and resources are always readily available, whether you're troubleshooting a problem or seeking to learn more. With these benefits, TensorFlow proves to be an indispensable tool in neural network computations. In the short span of today's discussion, we have traversed the path of understanding TensorFlow's role in neural networks. We began by exploring what TensorFlow is, an open-source software library for machine learning and artificial intelligence. It's a tool that enables us to create and train complex models with relative ease. Then we delved into how TensorFlow interacts with neural networks, We learned that it's all about data flow graphs, where nodes represent mathematical operations and edges denote the multidimensional data arrays, or tensors, communicated between them. Finally, we touched on the benefits of TensorFlow. It's not just about its computational efficiency or its ability to scale from a single CPU to a whole cluster of servers. It's also about its flexibility, offering support for a variety of languages, and its robustness with an active and growing community. With TensorFlow's power and flexibility, it's clear why it's such a crucial tool in the world of neural networks and machine learning.